we have seen how compound interest can be calculated using tables. But the procedure was very long. So in this video, we will figure out a formula to calculate compound interest. Let us quickly derive the formula. Let P be the initial principal and let R be the rate of interest per annum. We will derive a formula for the amount at the end of n years. First, let's just look at annual compounding. We make columns of years, principal, interest, and amount. For the first year, the principal will be P. So the interest will be PTR divided by 100. That is P multiplied by 1 multiplied by R divided by 100. P is the principal at the start of the year. 1 is the time period in years and R is the rate per annum. This is also equal to PR divided by 100. The amount for the first year will be this plus this. P is common to both the terms. We get the amount as P multiplied by 1 plus R by 100. This is the amount we will get if we withdraw the money after a year. Since we're trying to find the compound interest, this will be our principal for the second year. In the second row, we write P multiplied by 1 plus R by 100 as the principal. So the interest for the second year will be this multiplied by 1 multiplied by R divided by 100. It is the same formula we used in the row above. Just that instead of P, we use this as our principal, which equals P multiplied by 1 plus R by 100 multiplied by R by 100. P multiplied by 1 plus R by 100 is common to both the terms. Hence, this can be written as P multiplied by 1 plus R by 100 multiplied by 1 plus R by 100. These two are the same binomials. Hence, this can be written as P multiplied by 1 plus R by 100 the whole squared. Look at the trend. For the first year, it is just 1 plus R by 100. In the second year, it is 1 plus R by 100 the whole squared. P remains common. Let us move on to the third year. This becomes the principal for the third year. We use the same formula for the interest. The interest will be this multiplied by 1 multiplied by R by 100. This can be simplified as P multiplied by 1 plus R by 100 the whole squared multiplied by R by 100. We add these two terms to get the amount. P multiplied by 1 plus R by 100 the whole squared is common to both the terms. So we get the amount as the common term multiplied by 1 plus R by 100. And we get the amount at the end of the third year as P multiplied by 1 plus R by 100 the whole cubed. So for the 2 time periods, this is squared, and for the 3 time periods, this is cubed. The formula can be generalized as the amount received will be P multiplied by 1 plus rate per annum by 100 raised to number of time periods. Instead of making a table by forming 4 columns, we will get the amount due in just one line using one formula. Notice that we get the total amount in the formula and not just the interest. We know that the total amount equals the principal plus the interest accrued. So the interest is calculated as total amount minus the principal. And remember, this P is the initial principal. So if it is compounded annually, the rate per annum will be R and the number of time periods will be N. The amount received will be P multiplied by 1 plus R by 100 raised to N. But what if it is compounded half yearly or quarterly? Do we have to derive another formula? No, we don't. We need to just modify this one. If compounded half yearly, then what will happen to the number of time periods? As there are 2 half years in a year, they will double. and the rate of interest for each period will be half that of the rate for a year. So the amount will be P multiplied by 1 plus R by 2 divided by 100, the whole raised to 2n. How did we get this? The rate is divided by 2 since we are calculating interest for 1/2 year at a time, and the time periods are doubled as each year has 2 half years. Similarly, if interest is compounded quarterly, the total amount will be P multiplied by 1 plus R by 4 divided by 100 raised to 4n. We get this formula as there are 4 quarters in a year.